Two ancient forces meet. No words, no warning, just muscle and instinct colliding in silence. Their bodies can kill with a single strike, yet what drives them isn't rage. It's programming, millions of years of evolution written into their DNA. When two giants of the wild cross paths, it's not chaos, it's biology calculating survival. Each heartbeat, each coil is a decision. But why would one serpent fight another of its kind? Territory? Food? Or something deeper? An ancient code that says, only one may rule this ground. What seems like brutality is nature running its oldest algorithm. Before the clash, we must understand who they are. On one side, the Mussurana, the black snake of South America, a predator built for patience and precision. Its dark body absorbs heat. Its muscles flow like liquid steel beneath the skin. On the other, the racer snake, fast, alert, driven by reflex rather than logic. It strikes first and questions later. Both are apex hunters in their domains, yet evolution shaped them for opposite strategies. The Mussurana calculates, the racer reacts. One kills by constriction, the other by speed and venom. When nature creates two masters of survival, conflict becomes inevitable. Their encounter isn't personal. It's ecological balance in motion. Two designs competing for the same blueprint of dominance. A snake's body is an orchestra of precision. More than 400 vertebrae move like gears inside a living machine. Each muscle segment connects to the next, generating waves of motion that can twist, climb, or strike with surgical accuracy. The Mussurana's internal structure is thicker, heavier, built to wrap and hold. It constricts with mathematical control, pressure increasing per millisecond until blood stops flowing. The racer's body, by contrast, is engineered for bursts. Light bones, rapid contraction, minimal drag. When it moves, it becomes a ripple of acceleration. Scientists have studied these mechanics for decades, trying to replicate them in soft robotics. But no algorithm or motor can yet match the efficiency of nature's own design, muscle guided by instinct, precision guided by survival. Power in snakes isn't about size, it's about energy conversion. Every coil stores potential force like a spring, waiting to release. When the Mussurana strikes, it transfers that energy through its spine, locking its prey in a grip that functions like a living hydraulic press. Within seconds, circulation collapses. Meanwhile, the racer's power lies in momentum. It doesn't need to hold, it overwhelms with speed and venom. Venom that evolved to paralyze neural signals faster than the prey can react. This isn't violence, it's efficiency. Each movement is measured, each decision guided by the physics of survival. When science watches these encounters, it doesn't see chaos. It sees algorithms written in flesh, the logic of evolution solving the equation of who lives and who doesn't. A snake doesn't just see, it feels the world. Through heat pits, vibration sensors, and chemical receptors on its tongue, it builds a 3D map of its surroundings. The Mussurana uses its forked tongue like a radar, sampling invisible particles in the air to track prey. The racer depends on motion, detecting pressure waves that travel through soil and air. Both species operate with precision far beyond human perception. To them, vision is optional, survival isn't. Scientists call this multimodal sensing, but evolution calls it survival architecture. Every breath, every flicker of the tongue, delivers information that can mean the difference between dominance and death. In a fight between giants, the one who reads the environment faster writes the outcome. These serpents are not villains, they are regulators. In their ecosystems, they balance populations, recycle energy, and prevent chaos. The Mussurana keeps venomous species in check, using its immunity as a biological advantage. The racer controls smaller snakes and rodents, ensuring the balance of the food chain. When their paths cross, nature observes its own test of design. It's not about cruelty, it's about optimization. Who adapts better continues the lineage. In this battlefield of silence, instinct is the only language. Each snake represents a chapter of evolution's experiment, one that never truly ends. Because in nature, perfection isn't static. It's rewritten every time two predators meet and force the laws of life to prove themselves once again. Survival isn't learned, it's remembered. Inside each serpent, instincts run deeper than thought. When the Mussurana senses danger, its body enters calculation mode. Every movement, every breath becomes data. The racer, in contrast, reacts before awareness even begins. Its neurons fire in microseconds, transforming fear into motion. This is the biological code of survival, millions of years refined into reflexes. The eyes are still, but beneath the skin, chemistry explodes. Adrenaline surges, muscles tighten, blood pressure rises. Each system aligns toward a single purpose: endure. Nature doesn't reward strength or intelligence alone, it rewards precision. The snake that wastes nothing survives everything. A human blink takes 300 milliseconds. A snake strike? Less than 70. That's how evolution compresses time. In those milliseconds, physics and instinct become one. The racer's muscles release in a wave, pushing air backward, propelling its head forward at nearly 20 times the force of gravity. The Mussurana waits, calculating trajectory, tension, opportunity. When it moves, it doesn't miss. Scientists studying high-speed footage call this predictive targeting. It's as if the snake anticipates the opponent's next motion before it happens. In reality, its brain processes vibration, air pressure, and sense simultaneously, a biological supercomputer operating in silence. No thought, no hesitation. Only code executing itself. The eyes may not see everything, but the heat does. Hidden behind the serpent's lips are thermal receptors capable of detecting a temperature change as small as 0.003 degrees Celsius. To a snake, every warm body glows like a beacon in total darkness. The racer uses this vision to detect movement in the chaos, the Mussurana, to aim for vital zones. Through heat, they read emotion, fear, tension, exhaustion. It's an invisible dialogue between predators, a war fought in wavelengths humans can't perceive. For the snake, the world is not divided into light and shadow, but into life and potential prey. Evolution turned temperature into language, and survival became fluent in it. A snake's power doesn't come from rage, it comes from control. Each coil acts as both weapon and sensor, adjusting pressure with mathematical precision. When the Mussurana wraps its prey, it measures heartbeat frequency through the vibrations under its skin. Once the pulse fades, the pressure stops. No energy wasted. The racer's body, on the other hand, works like an elastic circuit. Energy builds in its spine, then releases in an explosion of motion. Scientists call this kinetic intelligence, muscle fibers responding to feedback faster than the brain itself. In these reptiles, thought is distributed, not centralized. Every muscle is a decision maker, every movement a calculation. What looks like instinct is actually engineering. In nature, survival is not about fighting harder, it's about fighting smarter. Both serpents understand this, without ever learning it. The Mussurana saves energy, striking only when success is certain. The racer never commits fully, it tests, evades, returns. This rhythm of attack and restraint keeps them alive. It's evolution's version of strategy. A human army trains for years to master timing and efficiency. A snake is born with it. Every action is optimized to achieve maximum outcome with minimum cost. That's the core of nature's code. Conservation equals continuation. In the silent logic of survival, hesitation is death, but patience is power. And that's why, when two giants move, the forest holds its breath. The forest falls silent. Two bodies slide over the same patch of ground, one dark and coiled, the other bright and trembling with motion. Their tongues flick, tasting data invisible to the human eye. The racer senses danger, but curiosity overrides instinct. The Mussurana doesn't chase. It waits. Stillness becomes tension. Tension becomes potential energy. Then a flicker, movement faster than sight. The racer strikes first, its head a blur, fangs cutting through air. The Mussurana absorbs the impact, twisting its body to redirect the force. What looks like chaos is pure calculation, physics expressed through flesh. Each serpent studies the other in real time, adapting, correcting, surviving. For them, this isn't a fight. It's a test of biological design. A snake's confrontation isn't emotional, it's mathematical. The racer attacks to measure distance, not to kill. The Mussurana counters to measure strength, not to escape. Every move feeds information into an ancient feedback loop: heat, vibration, muscle resistance. It's biology running simulations faster than any computer could. Scientists observing such encounters describe them as dynamic equilibrium. Each snake tries to read the pattern of the other, waiting for the smallest mistake. A single miscalculation in angle or pressure could mean death. Yet neither panics. They are calm algorithms. The forest sees violence, nature sees calibration. The battle is simply the language of adaptation, spoken in muscle contractions and heartbeats per second. Inside their bodies, chemistry takes command. Adrenaline surges, converting stored energy into explosive motion. Cortisol rises, sharpening focus while suppressing pain. Blood vessels constrict to preserve oxygen. The racer's heart races beyond 200 beats per minute, its muscles burning through glycogen reserves like fuel. The Mussurana's system remains steady, colder, conserving energy for endurance. Two strategies, two metabolisms, one built for bursts, the other for control. Through thermal vision, each can see the other's heat fluctuating, glowing hotter with stress, fading with fatigue. It's like watching life as infrared mathematics. Beneath the scales, biology orchestrates its own form of warfare, silent, chemical, unstoppable. To the untrained eye, the struggle looks random. But every coil, every twist, follows rules, geometry, leverage, torque. The racer aims for the head, trying to immobilize vision and breathing. The Mussurana rotates counterclockwise, forcing the opponent's weight into imbalance. This is muscle chess. Every move predicts the next, every counter creates an opening. What separates the victor isn't aggression, it's efficiency. The one who spends less energy wins. In labs, biologists have measured the mechanical power of constriction, noting how snakes regulate pressure to avoid wasting force. The Mussurana's strength is patience, the racer's is acceleration. When opposites collide, nature reveals its most elegant paradox, power through restraint. Minutes pass like seconds. The confrontation slows, yet neither retreats. Their systems run on instinct now, no emotion, no thought, just execution. The racer weakens first. Bursts of movement cost too much. Its body, overheated and oxygen-starved, begins to tremble. The Mussurana tightens its grip, muscles pulsing like a living machine. This is not cruelty. This is the completion of a biological process older than mammals, older than fear itself. The forest watches as one rhythm fades and another continues. The winner doesn't celebrate, it simply breathes, calibrates, and resets. Because in nature, victory isn't triumph, it's equilibrium restored. The code has run its course, and the algorithm of life moves on. Beneath the skin, an invisible battle unfolds. The racer's bloodstream floods with adrenaline, pushing oxygen to every muscle fiber. Mitochondria burn glucose at a frantic pace, producing energy and lactic acid. Pain sensors flare, but evolution built filters to silence them. Meanwhile, the Mussurana's blood chemistry remains stable, its red cells thicker and slower, engineered for endurance. Microscopic ruptures form along muscle fibers as the two bodies twist, but specialized repair enzymes immediately activate. Evolution designed these systems not for victory, but for recovery. Even in combat, life prepares to heal itself. What the eye sees as violence, biology interprets as adaptation in progress, survival rewriting the body in real time. As the fight continues, oxygen becomes the rarest currency. Every breath must count. The racer gulps air through rhythmic contractions, its rib cage acting like a bellows. The Mussurana does the opposite. It holds its breath, lowering heart rate to extend energy reserves. Thermal cameras in laboratory simulations show how internal heat spreads unevenly during combat. Localized spikes mark muscle exertion, while cooler regions reveal strategic control. The racer's body glows bright red under infrared, a signal of burning energy. The Mussurana remains dark, calm, efficient, surgical. In these differences lies the essence of biological strategy. One burns to survive, the other conserves to dominate. Inside the Mussurana, venom proteins from previous hunts circulate harmlessly. Its blood contains specialized molecules that neutralize toxins from pit vipers and coral snakes. Scientists call this cross-immunity, an evolutionary shield coded in DNA. When bitten, its plasma dissolves venom compounds before they reach critical organs. The racer has no such defense. Its physiology depends on evasion. This difference turns biochemistry into fate. Meanwhile, both snakes trigger hormonal feedback loops, bursts of dopamine and serotonin regulating focus, fear, and drive. Yes, even reptiles feel a form of reward. Each successful move releases micro-pleasure signals that reinforce survival behavior. The brain learns through battle, not emotion but chemistry. In nature, the body often outlasts the mind. As oxygen drops, the racer's neural activity begins to fade. Electrochemical noise replaces ordered firing. Yet its muscles keep moving, a phenomenon known as post-neural persistence. Even after consciousness fades, calcium ions trapped inside muscle fibers trigger contractions for several seconds. It's as if the body refuses to accept defeat. The Mussurana senses the change. It loosens its coils slightly, maintaining grip only until all movement stops. At the cellular level, both organisms are operating on autopilot, self-regulating systems that require no decision, no willpower. Biology doesn't ask for mercy. It simply executes the program written by evolution. When the forest quiets again, science continues its work. Micro tears in the Mussurana's muscles release growth factors that accelerate repair. Within days, new fibers replace damaged ones, stronger than before. Its immune system cleans the bloodstream of toxins and debris. The racer, if it survives, begins its own process, shedding skin, replacing cells, resetting its chemistry. Nature wastes nothing. Even the struggle becomes data, stored in DNA, refined for future generations. Every scar is a lesson written in protein. That's the unseen beauty of evolution. No moment is lost. Every heartbeat, every wound, every breath feeds back into the system that keeps life endlessly learning how to endure. Long before cameras, nature kept its own records, fossils and scars. Paleobiologists have uncovered remains of giant snakes with crushed vertebrae, evidence of prehistoric combat between titans. Some species, like Titanoboa, could reach lengths of over 12 meters, capable of swallowing crocodiles whole. Others, smaller but venomous, evolved speed instead of mass. These ancient duels shaped the evolution of modern serpents. Each clash was a biological experiment, testing which design of predator endured best. Strength alone never guaranteed survival. Adaptability did. The genes that coded patience, stealth, and energy control outlived brute force. Every modern snake carries echoes of those ancient wars written into its DNA. Among reptiles, few mysteries fascinate scientists like venom resistance. The Mussurana's immunity to pit viper toxins isn't luck, it's molecular adaptation. Its blood contains antibodies that bind to venom proteins before they reach vital tissues. Over centuries, natural selection favored those individuals that survived bites. Today, their descendants hunt venomous snakes without fear, turning a deadly disadvantage into dominance. Researchers are now studying these mechanisms to design antivenoms for humans. Evolution solved chemical warfare millions of years before we did. Nature was the first biochemist, perfecting immunity, one molecule at a time. In some regions, snakes don't just compete, they consume each other. Species like the king cobra or large constrictors often feed on smaller serpents, including their own kind. To human eyes, it looks savage, but to evolution, it's efficiency. Recycling protein, eliminating rivals, and sustaining the strongest. It's a closed-loop ecosystem that wastes nothing. Scientists have even documented serpents regurgitating prey too large to digest, proof that survival isn't cruelty, but calculation. The line between predator and prey blurs in the reptilian world, where life's only rule is to continue existing, no matter the cost. Imagine if humans inherited serpent instincts, thermal vision, pressure sensors in skin, or muscles that react faster than thought. Cities would pulse like ecosystems filled with heat signatures and silent communication. Decisions would happen in milliseconds, emotions replaced by precision. Survival would no longer depend on technology, but on biology perfected by evolution. The snake shows us what humanity traded for consciousness: instinct for reflection, efficiency for complexity. Yet both are forms of intelligence. One built from neurons, the other from time. And when we watch these reptiles move, part of us recognizes that forgotten rhythm, the original code of survival. In the end, there is no hatred on this battlefield, only design. What we call brutality is simply the language of balance written in muscle and movement. When two serpents collide, nature isn't choosing sides, it's refining perfection. Each clash reaffirms a principle older than the planet's forests. Nothing survives by chance. Mussurana and racer are more than predators. They are extensions of the mind of evolution, algorithms made of flesh, executing instructions refined by millions of failures and a few magnificent successes. Beneath their scales lies the same logic that shapes galaxies and governs atoms: adapt or disappear. To human eyes, the battle ends when a body stands still. But in truth, it never ends. The victor carries forward the code, slightly improved, slightly altered, ready for the next test. The loser also contributes, in data, in DNA, in the silent equation of life. Through them, the system learns. This is how the world evolves, not by mercy, but by mathematics. Yet there is something almost poetic about it. Watching them, we see ourselves. We too struggle, adapt, and rewrite our patterns in search of survival. We invent technology, build empires, and pursue progress, but the principle remains the same: conserved energy, calculated risk, restored balance. Snakes remind us that intelligence is not defined by words or machines, but by the efficiency with which life continues. They are neither villains nor heroes. They are proof that nature's design never wastes a single movement. And as silence returns to the forest, what remains is not fear, but wonder. Because in that silence, you can almost hear evolution thinking. If you've reached this point, you already understand. In nature, cruelty does not exist, only purpose. And if you want to continue discovering the hidden intelligence behind every strike, every scale, and every heartbeat of nature, stay with us. Subscribe to the channel and continue exploring the science behind Earth's most extraordinary creatures. Because nature doesn't just fight, it calculates. And each shock brings us one step closer to understanding the code of life itself.